Yesterday we talked about zero and one dimensions. A zero dimension is a point, one dimension is a line, a segment, or array. Today we'll talk about two dimensions. Two dimensions, unlike a line that only has length, two dimensions has length and width. So there's a lot of shapes you could probably imagine that are two dimensional. Basically, any shape that I can draw on this slate is two dimensions. So a triangle is two dimensional. It doesn't rise up off of the whiteboard or the slate. It just has length and width. A circle is two dimensional. It doesn't rise up off the slate like a cylinder. A square, a rectangle, a parallelogram. You get the point here. Any kind of shape that I can draw on this slate is two dimensional. It has length and it has width. It's not just like a line that only has length, and it's not like, say, this eraser that has length, width, and height to it. It comes up off of the slate. That'd be three dimensional, and that's what we're going to talk about tomorrow. So, two dimensional, there's a ton of two dimensional shapes that all fit into one general shape or general category, and that category or shape or definition that we're going to use is called a plane. All right, a plane is basically a two-dimensional shape like I just drew, a circle, a square, a rectangle, but imagining it extending out in every direction forever. So a plane, just like a line, is infinite. It goes off in two dimensions forever. So you can't say it goes off in every direction forever. All right, that's the tricky part with this. A lot of times planes are drawn as a parallelogram. You might say, okay, it's a plane, imagine it going off in every direction forever. Well, if you say every direction, you're talking about up off the slate as well, and that makes it three-dimensional. So you can't say it goes off in every direction forever, but it goes off in the two-dimensional directions forever. So you could make this plane as big as you wanted. This is still the same plane. It's just bigger. It's growing. It doesn't have to grow every way. You could just grow it this way and say that's still the same plane. All right. So it goes off in every two-dimensional direction forever, not every direction forever. All right. But that's a little bit of a sloppy definition. What we're going to use to define a plane is 3 points. All right, think back, let's step back to yesterday for a second. A line was one dimensional, and to make a line, we needed 2 points. All right, if you have 2 points, you can connect that with a line, and that's a one-dimensional shape. So a plane, now we're stepping up to the next dimension, 2 dimensions, we need another point. Instead of having 2 points that we needed for the line in one dimension, now we need 3 points to make a plane. All right, because if we only have 2 points, all we have is length. We don't have our second dimension of width. If we add a third point in there, now we have length and width, and we have a plane. All right, so a key concept to take from this is that any 3 points makes a plane. It is absolutely impossible to come up with 3 points that are not in the same plane. And that's a little bit hard to wrap your mind around. All right, it's easier to imagine 2 points, any 2 points, just say floating around in the room, you can connect with a line, and that's a line, one dimension. You can always connect 2 points. The shortest distance between 2 points is a line. It's a little bit harder to imagine 3 points floating around in the room and be able to connect them all in the same plane. So I've come up with an idea to try and show you a visual of how that works. And I'm going to use a standing table, which I have laying down on my table island right here. So here's my standing table, and it has 3 legs. 3 legs on a standing table, and we're going to say the bottom of these legs are 3 points. So here's 1 point, 2 points, and the third point is right there. And how I'm going to do this is tell you that if you have a table or a stool or a chair that has 3 legs on it, it will never ever wobble. You know how you get on a desk sometimes and they wobble, or you sit in a chair and it wobbles? It's because it has 4 legs. And if you have 4 points, they're not necessarily in the same plane, but 3 points are always in the same plane. So think of it like this. Here's 2 points that are 2 of the points at the end of the leg are on the table. The third point is always going to hit the ground, and it's not going to wobble. The 3 points are always going to be on the ground. All right, these 2 tables are pretty flat. Here's a desk back here that's a little higher up. So you imagine 2 of them are on the higher up table, they're flat, and you try and get this third one down a little lower, it still doesn't wobble. All 3 legs are on the ground. Your plane is just shifted down a little bit now. So that's maybe can help you imagine 3 points floating around in the room. You can always connect them with a flat surface. You can always connect 3 points with a plane, and a 3-legged chair or a 3-legged table will never wobble because the bottom of the legs will always be in the same plane, regardless of whether it's on a slope or if it's flat. They're never going to wobble. All right, even if this leg was way shorter, it would eventually sink down and hit the ground, and then it wouldn't wobble. So it works. Now, let me show you the converse. The example of why 4 points don't necessarily have to be in the same plane. Here's a desk with 4 legs on it. So again, we'll imagine the bottom of the legs are 4 different points. So you could set 2 of the legs on the ground. The third leg touches the ground. You've got 3 points that are touching the ground. It's not going to wobble. But that 4th leg, it's short. It's not on the ground. You can see I can put my hand right underneath it. It's not in the same plane as those. If I try and get it in the same plane and tilt it so that it hits, now this one's raised up off. So that's how you get a wobbly desk or a wobbly chair, is that your 4 legs aren't in the same plane. So it's not that it's impossible. You can have 4 points in the same plane. In fact, there's an infinite amount of points in a plane. But if you just pick 4 random points floating around in the air, you're not necessarily going to be able to connect them with a flat plane. They're not necessarily on the same plane like 3 points are. 3 points are always in the same plane. 4 points, not necessarily. So when you see a picture of a plane, it's usually drawn like a parallelogram, and it'll have 3 points in it. So when we labeled a line yesterday, you had to have 2 points, and I called them AB. Line AB, ray AB, segment AB. Now we have a plane, which is typically designated with a parallelogram, and you have to have 3 points in that plane. Because 2 points is just a line. 3 points makes a plane. So this would be plane ABC. So that's plane ABC, 3 points. And that's a plane. Now, these 3 points that are in the same plane are called coplanar. Co, like cooperate, it means to work together, to share. Co kind of means together. So these are coplanar. They're sharing the same plane. They're in the same plane. And you could also say that you have points that are in the same line, like say A and B. Those are called collinear. So any given 3 points are always coplanar. Any given 2 points are always collinear. You add a third point to a line, or a random third point by this line, it's not necessarily on the same line. So say this point C right here. That's not on the same line as AB. All right, a line has to go straight. It can't have any bends or breaks or curves in it. So there's no way to connect a straight line that goes through A, B, and C. You'd have to break off from A and create another line. So A, B, and C are not collinear. A and B are collinear, but you throw C off the line, now they're not collinear. C is not collinear with that. So collinear means they're in the same line. Coplanar means they're in the same plane. So A, B, and C, those are coplanar. But say I want to try and draw like a Rubik's Cube here, turn this plane into a Rubik's Cube. It would look something like that. and say this point up here, we'll call that D. That is not coplanar with A, B, and C. It's not in the same plane anymore. It's rising up off of the slate. Technically, it's not. I drew it on the slate, but I'm trying to draw a three-dimensional figure here. I'm trying to draw like an eraser. So the top of this corner of the eraser is not in the same plane as the points on the bottom of the eraser. All right, so just like adding a third point to a line, you might not be collinear. If you add a fourth point to a plane, you might not be coplanar. You could be if the point you added was on the bottom of this Rubik's Cube and that was point E. Well, then point A, B, C, and E are still coplanar. They're all on the bottom of the Rubik's Cube. They're on that plane on the bottom of the cube. Anything off the bottom of the cube is not coplanar. So that's what coplanar and collinear means. A plane is a two-dimensional shape, and it's defined by any given 3 points, just like a three-legged stool will never wobble because they're always on the same plane. 3 random points are always on the same plane.